Hello everyone, welcome to the Information Theory and Coding course. Today we are going to discuss about a new model called as source coding. In this source coding, we mainly focus on how we can convert this source alphabet into code alphabet. If you remember the model number 1, the block diagram, that is the Information Theory and Coding block diagram if you see here. So what we had is, we had a source alphabet, that is a transmitter we had, discrete source information we had, and from the discrete source information it was given to the source encoder, and from the source encoder it was given to the channel encoder, from the channel encoder it was given to the modulator. The modulator will modulates the given signal, that is a digital signals, and it will be transmitted over the channel. At the receiver end, the decoder, that is a demodulator, will receive the channels and it will convert the electromagnetic waves into suitable digital form of signal. And the channel decoder will do the decoding operation. So whatever the redundant information which has been added at the source channel encoder at the transmitter, which will be removed from the channel decoder, and then it will be given to the source decoder. The source decoder, what it does is, it will decode the given symbol, that is, it will convert back the binary stream of data into finite number of source alphabet. So that is the overview of what we have learned in the module number 1. And also, to brief about the model number 1, what and all we have learnt is, in the model number 1 we learnt about a measure of information. Means if a discrete source emits some distinct number of symbols, means what is the amount of information conveyed by each source we measured through the use of self information using a logarithmic scale. And after measuring the source self information, then we went on measuring the average information about source symbols which has been emitted from the discrete memory less source. And we studied about several problems which are associated with to find the entropy of the signal. And after that we go for a extension of the source alphabet. Means if you have a source alphabet with s is equal to 2 symbols, then it is possible for us to extend this 2 symbols into a higher number of bits by using the extension of the symbols. And we know that the extension of the entropy of the source, that is s power n, is nothing but it is n into entropy of the original symbol. So all these details we studied in the module number 1. And after that we went for the average information content of the dependent symbols, that is nothing but we studied about a Markov model. So in the Markov model, whenever source exhibits or whenever a source emits any particular symbol, it depends upon the previous q number of symbols what it has been emitted. Based upon that, the next symbols will be generated. We have used a trellis diagram, and that is a tree code diagram, and through the use of tree code diagram it is possible for us to identify, or it is possible for us to find out the energy per bit or the entropy of the given source alphabet. Either it may be 1 bit per symbol, it may be 2 bit per symbol, or it may be 3 bit per symbol. Now, after successful understanding of how we can convert the source alphabet through the use of probability values into an average amount of information conveyed by the message, the next step is how we can convert these bits of information into through the use of the code words. So that is how we use this source encoding mechanism. In this source encoding mechanism, what it does is, it will convert the source alphabets into code alphabets. So generally the code alphabet in the digital transformation we will be using a binary only. So therefore you can see here, source encoding, it is a process by which the output of an information source is converted into an R array sequences, where R is nothing but the number of symbols, different symbols what we are going to use for the transformation. As I said, if it is a binary case, means then R will be 2. So means we will be using only 2 symbols to represent them value, either in 0 or it is 1. If it is a ternary case, means then R we will be taking the value 0, 1, 2. And if it is a quaternary value, then R will take a value is equal to 4. And the different number of symbols for the quaternary we will be using as 0, 1, 2, 3. These are the symbols what we are going to use. So basically a source encoder, it is nothing but it converts a source alphabet into code alphabet. Then before we go for how exactly we are going to convert this source alphabet into code alphabet, it is necessary for us to know some of the characteristics of the code words what we are going to generate. So that is why it is necessary for us to understand some of the properties of the code words. So the first one we call it as a block codes. So what do you mean by block code? A block code, it is a code in which we map each symbols of the source alphabet S into some code alphabet. So if you consider a binary value, it is possible for all the symbols, it is possible for us to create a code alphabet. So in the given example, you can see here a source S, it is having 4 symbols, S1, S2, S3 and S4, and this we call it as a source symbols, that is it is emitting the sequences. And for these symbols, we need to have the transformation, or we need to have the mapping of the code blocks. So we have created a code block X, so in such a way that S1 will be represented with a 0 0 and S2 will be represented in the form of 0 1 and S3 will be represented in the form of 1 0 and S4 will be represented in the form of 1 1. A block code is nothing but it is a set of code words which we are going to map to the source alphabet, that we call it as a block code. The next one we call it as a non-singular code words. So what do you mean by non-singular code word is, so if each code words are distinct and each source alphabet it is having a different code words, means then the such a type of code words we call it as a non-singular code words. For example, in the given case you can see here S is having a 4 symbols S1, S2, S3 and S4, and each S1, that is the code alphabet, it is having a different values for each symbols. So for example, for the S1 we have coded as 0 0, for S2 we have coded as 0 1, and for S3 we have coded as 1 0, and for S4 we have coded as 1 1. So means what, each code alphabet it is distinct and it is not repeated for the source alphabet mapping. So therefore such a code words we call it as a non-singular code words. And the next one we need to know uniquely decodable code words. So what do you mean by uniquely decodable code words is, so if you have a source symbol and for this source symbols you have mapped to a code alphabet. Now if I go for the second extension, in the second extension also the code words, if there is no any the same set of code words, if you are allocating for the different source alphabet, means then we can say that the given set of code words are non or unique, it is non-uniquely decodable code words. So therefore the definition of non-singular code words, you can see here, a non-singular code word is said to be uniquely decodable if and only if the nth extension code words of the code is non-singular for every finite value of the n. So means what, if you have a source alphabet and if you have a code alphabet, and these source alphabet and code alphabet are distinguishable from each other, and if you go for the second extension also the code word has to be distinguishable, and if you go for the third extension also the code word has to be uniquely distinguishable. So such a code words we call it as a uniquely decodable code words. The next one we call it as a instantaneous code words. So what do you mean by instantaneous code word is that the moment when you receive a data at the receiver end, it is possible for you to identify, or it is possible for you to remap with the source symbols. Such a code words we call it as a instantaneous code words. In order to understand what you mean by the instantaneous code words, so let us have a look over here. So we have a source symbols. So we have a S1, S2, S3 and S4, and these source symbols has been mapped with a two different category, that is we have a one type of code word block and another type of code word block, and we have another type of code word block over here. So you can see here S1 has been mapped through a code word A, that is S1 is 0 0, S2 is 0 1, S3 is 1 0 and S4 is 1 1. Similarly for the code B, you can see here S1 is 0, S2 is 1 0, S3 is 1 1 0, S4 is 1 1 1 1 0. Similarly for the code word C, you can see S1 has been mapped to 0, S2 has been mapped to 0 1, S3 has been mapped to 0 1 1 and S4 has been mapped to 0 1 1 1 1. Now let us try to understand what we mean by instantaneous code words. So in order to understand what we mean by instantaneous code words, we need to consider some received sequence. Based upon the received sequence, how we can easily possible to decode at the receiver end, it is possible for us to identify. So therefore, I have considered a receiver sequence, an arbitrary received sequence I have considered 0 0 1 1 0 0. So this is the data what I am going to receive at the receiver end, and based upon these receiver sequences, I need to map to the source alphabet. So if you are using for a code set A, then how it can be decodable, you can see here. So when I receive 0 0, the moment when I receive 0 0, I can code it as it is belongs to S1. Similarly, when I receive a value 1 1, then I can easily decode it as it belongs to S4, means I can decode it as S4. Similarly, when I receive a 0 0, again 0 0 it belongs to S1, so I decode it as S1. So therefore, when I receive 0 0 1 1 0 0 at the receiver end, if I use this code word A, then I can easily decodable, that is S1, S4 and S1. Similarly, you can see here for the code B, so you can see the moment when I receive 0, so the 0 has been decoded as S1. Similarly, again when you receive 0, the decoded as S1, and when you receive 1, so 1 is not there, that is why I need to wait for the next symbol 1. So 1 means again it is not there, so next what I should do, I should wait for the number symbol 0. So 110 means I will be decoding it as S3. Similarly, for the next symbol is 0 means I will be decoding it as S1. So if I use a code block B, the given received sequence will be decoded as S1, S1, S3 and S1. Similarly, if I go for the code C, you can see the moment when I receive 0, I will be decoding it as S1. The moment when I receive 0, I need to wait, which is the next symbol has to be decoded. So therefore, what I am going to do is I will be waiting. At the moment when I receive 1, so I need to again wait for the next symbol, what it is there. When I receive again 1, so I need to see what is the next symbol. So again, when I see that 0, so 0, 1, 1, it can be decodable as S3, and the next followed by 0, 0, it can be decoded as S1 and S1. So if you carefully observe the code C, it is having different notations. So I can decode it as S1, or I can decode it as S2, or I can decode it as, if you decode it as S2, it is not possible for you to see what is that 1, 0. So therefore, this code word C and code word B, we call it as a non-instantaneous code word, because the moment when they arrive the code word, it is not possible for us to map these code blocks into source symbols. So therefore, we call it as such a code words are non-instantaneous code words, whereas the code word A, it is an instantaneous code words. So there are some more different additional properties are there. So those properties we will see it in the next class. Thank you.